Hi, everybody. Welcome back. So we've been talking about change in momentum as being equal to impulse, and force times time being equal to impulse. So now we actually have a problem where we can put some values in and uh, see how they go. So let's see here. I'm going to see if I can shrink this down a little bit. I'm going to do that. All right, and give myself a little bit more space. So we have this guy jumping. He wins a game show and he jumps up. He's 72 kilograms. All right, so let's just go ahead and write that. Mass equals 72 kilograms, and he jumps with an upward speed of 2.1 meters per second. All right, well, that's the final velocity, right? As he's on the floor, he's like kind of crouching down. He's at rest, and so he pushes off, and then his final speed upon leaving the floor is 2.1 meters per second. All right, so his initial velocity is 0, and his final velocity is 2.1 meters per second. So the question is, what is the impulse experienced by the contestant? All right, so impulse I, that's what we want to find out. Okay? Well, let's go ahead and solve for that. So for part A, we want to find out our impulse I. Well, remember that impulse, it can be thought of as two different ways. It's force times time. Of course, we have neither right now. But what we do have is we have mass and we have velocity. And impulse is also described as a change in momentum. All right? That is momentum final minus momentum initial. Okay, so momentum final, what's that going to be? It's going to be mass times velocity final, right? And then momentum initial is mass times velocity initial. So what values do we have for that? Well, you know what I'm going to do? I'm just going to factor out the m. It's going to be m times v final minus v initial. All right, change in velocity, mass times change in velocity. And that's going to be 72 kilograms times final velocity, 2.1 meters per second minus 0. That's just going to be 2. It looks like a 6, doesn't it? That's even worse. Minus 0. Just going to be 2.1 meters per second. So what's that going to be for our impulse? I get 151 impulses. 151. What is impulse measured? Or it's a change in momentum, right? So it's simply going to be the same units that momentum has. So momentum is kilogram meters per second, and that's going to be our impulse. We can think of impulse as being, you can think of it as being a change in momentum, which he undergoes. He's got no momentum right here because he's got no velocity, but now all of a sudden he has momentum. So something has to be able to provide a force to cause that momentum to change. And what's doing that? Well, the floor is doing that. The floor is, he's pushing down on the force, but the floor is providing the normal force that enables him to push off of the floor and jump upwards. Let's pretend the floor was made of something very, very fragile, like cardboard. All right, if he pushed off the floor too hard, he could very well just put his feet right through the floor. So the floor has to be, we'll say, strong enough, or has to be able to support not just his weight, but also the force that he applies to it. Which, by the way, let's solve for that right now then. Part B is asking us, what is that force? Or you might say the average force that the floor has to exert in order for the guy to be able to jump upwards. All right, now the floor already has to support his weight, mg. All right, let's pretend that it can do that, but it also needs to be able to create enough upward force to cause that momentum change, to cause that impulse. All right, so our impulse is 151 kilogram meters per second. Let's solve for the force now. We also know, aside from impulse being change in momentum, the impulse is force times a change in time. Okay? So if we simply solve for force, what extra force besides his weight force does the floor have to exert? That's going to be his impulse divided by the change in time. Now in part B, the change in time is 0.36 seconds. Okay? So about a third of a second right there that he's in contact with the floor that he's applying that force to. And so over that amount of time, I'll fix my eye here. Over that amount of time, he has to apply a certain force to the floor. You might say the floor has to support him with that force so he can jump upwards. So that's going to be 151 kilogram meters per second over 0.36 seconds. All right, and that's going to be our final answer, which is, I get about 420 newtons. 420 newtons. Does that make sense? Does that unit make sense? Well, remember, a newton is a measure of force, right? We're measuring force after all. And our numerator is kilogram meters per second, and denominator is seconds, so it's going to be kilogram meters per second squared. And of course, that's mass times acceleration, which is what force is. So 420 newtons on top of what the floor was already supporting him with is what the floor needs to be able to do so that he can push off the floor and jump up to that velocity in that amount of time. If you did it over a longer period of time, it would be less force, but that's the nature of impulse. Force times time. So as time increases, force decreases, and vice versa. All right? That's it for example 9.3. Thanks for following along. I'll see you on the next one.